Hello and welcome back to the video lecture series on statistics for machine learning. This is Amit Kumar Das, and we are actually going through the different topics of statistics which are very important for machine learning, right? So we have already gone through the different concepts in the descriptive statistics, which is one very important part of the statistics used to navigate or explore the characteristics of the data, right? And the data basically means the input data to the machine learning algorithm. Now, after that, we also kind of got a very good idea about the theory of probability, which is like a stepping stone to the next step of statistics, which is the inferential statistics. So now we are going to start with the concepts of inferential statistics. First of all, what are the different? So first of all, what is inferential statistics all about? In a nutshell, if I just try to summarize the concept of inferential statistics, it is about getting an idea or getting some inference about the whole data set, or rather the whole aggregated population. And we're going to come what population means by a few samples, or rather some few portions of that entire population. So if we kind of make a notion of the whole population from the sample drawn from that population, that's what comes under the purview of inferential statistics. So very clearly there are two concepts under the hood of inferential statistics. The first, which is known as estimation of parameters. So say for example, I want to get an understanding of the overall parameter, say for example a particular population mean, right? So I have only a portion of the population in the form of the sample, right? So now using that samples metric, if I want to if I try to gauge or infer the value of the population metric, then that is known as, that particular thing is done as a part of estimation of parameters, right? We're going to get into details of that, but from a very overview perspective, this is what it means. The second part, which is also very important, is called hypothesis testing. Okay, so what does it mean? Again, in a very layman's term, if I have a particular question, or if I want to find out a particular property of a population as a whole, but I cannot do the testing, or I cannot do the evaluation based on the whole population. I have to do it on a small portion of the population, right? So what I try to do is I'm trying to answer to a question based on a small portion of the population, right? Which is the sample. So that is called the hypothesis testing. Say for example, I want to understand whether a particular medicine can work on the Indian population. Say for example, a particular vaccine which is used for COVID-19, whether it is going to work on the Indian population or not. I cannot apply the vaccine on the whole set of the population and then try to kind of come up whether it is going to work or not. So what I have to do is I'll have to make my evaluation based on a particular smaller set of the population, and we have our own ways, and we'll look into that. How can we do that? We can use that particular notion, or that particular experiment, or that particular evaluation on a very smaller set of the population to make the answer, or to come up with the answer for the whole population, right? So that comes under the purview of hypothesis testing. We are going to look into each of these elements very closely, and we are also going to look at how they are being utilized as a part of machine learning. But to start with, let's first try to understand a very few, very basic concepts related to population and sample, because that's the first thing that everything starts with. Okay, so let's first do that. So first of all, what is a population? We all know we have a aggregate data set, right? Say for example, when we consider the whole population of India, right? Or rather the whole I mean, say student base of India. Let's not talk about the population because population and population that may get confused. So say, for example, the whole set of students in India, right? So that is my population. So I can have many such students as a part of Indian student population or Indian student data set, right? So each of these dots, say for example, represent one student, right? Now I have a small portion of this one. Okay, say I have this small portion. And how do I get this portion? Say I take a few dots from here and then I plug it in here. Okay, I take one from here, another from here, say one more from here. Okay, so one more from here. Okay, and so on and so forth. And I come up with the set of students, a smaller set of students. So this is called a sample. Okay, this is called a sample. And this unit, say these dots, represent one unit or one student in this whole population. So that is called the population size. Okay, so the total number of students which I find in this population is called the population size. And the number of units in this smaller bunch, right, in this smaller set is known as sample size. So population size for the whole population and sample size for the smaller part of the population, which is the sample, right? So sample size is always going to be lesser than the population size, because the whole idea is, since the population is huge and we cannot probably do certain things based on the entire population, we take a small portion of that and create a sample. So obviously the sample size is going to be less than the population size. Now here comes few things. First of all, how can I draw this population sample from the population? So there is a concept called simple random sampling. Okay, simple random sampling, or uh, it is also called just random sampling. Okay, so this process of drawing the sample from the population is known as simple random sampling or just random sampling. I mean, in short, it can be called as SRS. Okay, simple random sampling. What is it? So you make sure that you pick the units from the population and you put in here in such a way, you define such a mechanism that every unit in the population has got an equal chance to be picked up and to be a part of the sample. So equal chance of every unit in the population to be picked up. That is the way we draw simple random samples or random samples. Okay. Now there are two ways to draw simple random samples. Okay. So one way is called with replacement, and the other one is called without replacement. So SRSWR and SRSWOR. What do they mean? So it means that so in case of SRSWR first, with replacement, say for example, if I number each of these units in the population by a specific integer, say 1, 2, I just assign a serial number. Okay, 1, 2, 3, 4, like this, I number each of them. I give a serial number. Okay, so what I do is I pick up randomly I pick up one unit, and what I do is I simply bring it here. So the one I bring it here, but at the same time I put this one back, this unit with the serial number 1 back into the population. So next time when I again pick up another unit from the population, I have an equal chance of picking up one once more, or one more time. Okay, so one particular unit from the population can be picked up for the sample more than once. So that is called simple random sampling with replacement. Means I pick up and I put it back. I note the number and I put it back. So it is called with replacement. The other option is I pick up, say for example, the unit with the serial number 1, and I simply put it to the different tray, which is the tray of the sample. This is the smaller tray and this one is the bigger tray. So I pull up from this tray and put it in the smaller tray. Okay, and I don't put it back again to the bigger tray. So this is called without replacement. So once I pick up this unit from population, say with serial number 1, there is absolutely no way I can pick up that same unit with serial number 1 one more time. Okay, so this is called SRSWOR, or simple random sampling without replacement. Okay, both of these are very, very important concepts, and we will see later on that in machine learning how they are being used. Okay, now one more thing: how do you make sure that the random numbers being, or the numbers picked up, are being completely random? Okay, so for that there is a concept called, there is a random number table which exists. Okay, so there is something called a random number table. Random number table. So what is that? Basically, it's a sequence of few numbers. Okay, so there is a set of numbers in the random number table. Say 175. I'm just taking up very wild numbers here. Okay, it can be something completely different also. Okay, so like this, there are more such numbers. Okay, so what I do is, say for example, I have a population where each of the units have a serial number associated with it. Okay, so 1, then I have a 2, then I have a 3, like this, there are serial number associated. Okay, and the highest serial number is a say 81. Okay, say for example, there are 81 units in that population. Okay, so what I do is I simply pick up 2-digit numbers from here. Okay, say for example, I start from here. Again, where I start from in the random number table is also random. It's supposed to be random. Okay, and that can be also ensured when we are using the different codings in machine learning to do that. Okay, whatever. So say for example, I start here and first I pick up 05. So what does it mean? I am going to pick the sample with serial number 5 and put it in the in the sample. So I pick the unit with serial number 5 and put it in the sample. Okay, say the next one is 11. Okay, so next I go and pick up this 11. I come here, whatever is the 11th serial number for whichever unit, I pick it up and put it here. Okay, and again it depends whether I am doing SRSWR, that is simple random sampling with replacement, or SRSWOR. What will be the difference? Say for example, down the line I come up with, again I come up with this CO05. So if I am doing SRSWR, obviously I can again go and pick up this unit with serial number 5 and put it in the sample. But if I am going for a SRSWOR without replacement, then I cannot go for this one. So this one I'm not going to take up. So next one I'm going to go, say next one is 27. I'm going to go and pick up the unit with the serial number 27. Okay, 27. So I'm going to go and pick that up and put it in here. So that is where it differs. So what is a random number table? It is a sequence of numbers, and these numbers are supposed to occur in a very, very random way. There is some mechanism to ensure that. Let's not break our head on that. So how do we use that table? I pick up the numbers, or rather say whatever. I mean, if I need a 2-digit number, I pick up 2-digit numbers. If I have sequences or serial numbers having maximum of 3 digits, so I can pick up 3-digit numbers from here. So whatever number I'm picking up from here, I go to the population, whatever particular unit has that particular serial number, I will pick up that unit and I will put that as a part of the sample. If it is simple random sample with replacement, then the same ID can occur more than once. If it is simple random sampling without replacement, it can occur only once. Okay, so this is the whole concept of simple random sampling with replacement, without replacement, the random number table, and the whole process how a particular sample is being drawn from a population. I hope you understand till now. When we come back, we are going to now find out how it is mapped in the machine learning world. Okay, we will look into that. Okay, so stay tuned. Thank you very much.